Hello everyone, today we're looking at question 4 from exercise 10F of the Edexcel Statistics and Mechanics Year 1 AS Applied textbook. This is a question on connected bodies and more specifically a pulley question which we have in front of us. Now they don't give us a diagram, so I'm going to extrapolate the information from the question onto this diagram over here. It tells us we've got two particles A and B on a rough horizontal table, and B is hanging freely on the right hand side. It tells us there is a frictional force on the rough table on particle A of 24.5 newtons. Now friction is going to oppose the direction of motion. B in this scenario is going to move down, meaning A is going to move to the right, meaning the friction over here needs to be moving to the left of 24.5 newtons. Now we're not dealing with the coefficient of friction yet, that is something we do in the second year content, but we're looking at this scenario here and we always need to draw on the forces onto our diagrams to make it clear for us. So the particle B of 3 kilograms has a weight of 3g and tension coming in the opposite direction towards the pulley, and there is also on particle A its weight acting downwards of 5g, tension pulling it to the right, and a reaction force acting upwards over here which will be equal to 5g because there are no other forces acting in that vertical direction on particle A. Now looking at the scenario, particle A is going to accelerate to the right hand side and particle B is going to accelerate downwards. We show that by our double arrow. Now while we look at this, we are trying to find the tension and acceleration of the system. So for this we always do F equals ma, and we always do it in the direction of motion. So if we do F equals ma downwards on B, the equation that we create is the net force going down is 3g minus t is equal to 3a. That's equation number 1 with two unknowns, meaning we are going to be dealing with simultaneous equations. And then if we do F equals ma on particle A is moving to the right hand side. On A, we obtain the equation T minus 24.5 is equal to the mass is 5a. So we have over here our two equations, and from this what we do is we can add those two equations together to work out our acceleration. So if you write those above each other, we have 3g minus t is equal to 3a, and we have t minus 24.5 is equal to 5a. We can add those two equations together, meaning those t's will cancel out, giving us 3g minus 24.5 is equal to 8a. If we work this out, 3 times by 9.8 minus 24.5 and then divided by 8 gives us an acceleration equal to 0.6125 meters per second squared. We can then work out the value of tension by substituting back in to this formula over here, or either formula, but I'm going to sub into here. So T minus 24.5 is equal to 5 lots of 0.6125, and that gives us a value of T equal to 5 times by 0.625 plus 24.5, giving us a tension value of 27.5625. 27.5625. Now that's quite a standard question. The question where most people struggle with is part C, where they ask for the force exerted on the pulley. Now this pulley is in equilibrium. Actually, we look at this diagram, the only forces acting towards the pulley are these two tensions. So what there actually is occurring on the pulley is equal and opposite forces acting in this direction. A tension going like that and a tension going like that. So we've got two tensions, one going to the left and one going downwards to counteract this tension and this tension. So to show this, this is simply a force of T to the left, and a force of T coming down, putting these forces head to tail. And therefore, to find the overall force acting on the pulley, what we've created here is a right angle triangle. And actually, in this case, this is an isosceles triangle, but it's a triangle which we can apply Pythagoras to. This is the resultant force on the pulley over here. So to work out that value, what we can say is that the resultant force squared is equal to T squared plus T squared. Now T we've worked out to be 27.5625. So if we square that and add it to itself, we get F squared is equal to 1519, etc., etc., etc. And therefore, if we square root that value, we can work out the value of F, which gives us an answer of 38.98. So F is equal to 38.98 or 39.0 newtons. So all we've said here, when you're working out the force exerted on the pulley, you're looking at the forces which are created by the two tensions and then applying the same thing in reverse in terms of equal and opposite forces. I hope that's made sense. If it hasn't, please let me know or comment below. Take care. Thank you very much.